a reference variable in your C programming. So it is a reference. We are using this one for the referencing the other variables here. So that's why this pointer is called as a derived data type. Why it is called as a derived data type means so we need to use our primary data types, and based on that primary data types only so usually what is the data value for this pointers are means nothing but simply the memory addresses as their data values. Okay, so how these memory addresses may be available means whenever a particular variable is created, so automatically your computer is allocating some memory for that. So that computer allocated memory is where although suppose if I want to create a one variable, suppose I want to take a one variable. So let us, I'm creating the one variable, let us take int a, like that I need to create a one variable. Okay, so whenever I'm creating the variable like this, so whenever I want to create a particular variable, so let us, I'm creating a one variable here, int a. So I'm creating a one variable like this, int a. So if I declare the variable like this, so then your computer is allocating the some memory for me for this particular variable. So this is the memory location that is created in the computer's memory. Let us take this address location, for example, it is a 4001, for example. So this is the address allocated for me. Now whenever I am initializing the value for it, suppose if I take the a is equal to 70, if I take the value a is equal to 70 means the value 70 is stored in this particular location. The value 70 is stored in this particular location. Okay. So now if I create a pointer, now if I want to create a pointer, so usually the pointers are created based on the primary data type. Means I want to create a reference variable. This reference variable is pointing to which data type. So that's why I need to check that data type. Okay. So that is int. I am taking this int star some x. So I want to take int star x. So what is this int star x represents means it is also a kind of variable. So it is also a one kind of variable that is created in my computer's memory. Okay, with some address location, maybe some 5002, let us say. With that particular address, it will be created. Okay, so now, but this int star x and this int a both are not same. So why? Because of, so here I am using the a reference, this x is used as a one reference variable, where a is a ordinary variable here. So that's why directly I can assign the a is equal to 70, then 70 is assigned into that appropriate location, whatever the memory location that is created for my a. But if I create a variable like this int star x, then x is act as a reference variable. So here I cannot assign x is equal to some 90 like this. So this kind of initialization is not allowed. This kind of initialization is not allowed because of, so why it is not allowed means that the x is I declared as a reference variable. X is declared as a reference variable. Now what values I can assign to my x means that for my x, it is capable for taking the address of the other variables. Addresses means what values? So this kind of values, that is 4001, 5002, like that, whatever the memory locations that are created for us. So those memory locations may be taken as a data values. So that means here, now my x is capable for only taking the x is equal to that 4001. I can take that x is equal to 4001. What is this 4001? This 4001 is nothing but the address of my a variable. So usually how I can represent the addresses means the addresses may be represented with a symbol that is called as AND symbol, that is ampersand symbol. That is, we can specify the AND of a. That is x is equal to AND of a. If I specify AND of a means that this is address of a. So that is what. So that 4001 will be assigned to this x. Means what value is stored in this location? So in this location, the data value stored is here, the address of the my a variable, that is 4001 is stored in this. Okay, so if I assign like this x is equal to 90, so then that 90 is not stored in that particular memory location because of 90 is a ordinary value, whereas my x is a reference variable, where that reference variable is not capable for taking the ordinary values. It is capable for taking the addresses only here. So that's why it is capable for taking the address of another variable. Only the available addresses here is, suppose I have the 4001. What is this 4001? We don't know. What memory is allocated for this A? In my programming point of view, we don't know about the what address it is allocated here. So that's why in order to take the address of this particular variable, so what we have to do, we need to specify the ampersand of A. So then the ampersand of A means nothing but it is the address of A. The address of A is nothing but 4001. That 4001 will be assigned to this. So it is nothing but this particular thing is nothing but it is a pointer to this one. It is a pointer to this one. Simply. Okay. Simply what it specified means simply it specifies it is a pointer because of we are storing the address of this one. So that's why it is a reference to this one. So that if I want to access the value, whatever that 70 here we are having. So if I want to access that particular value, so how I can access means directly I can access the value with variable name A. So what it indicates? So A indicating the nothing but. So what it indicates? Simply it indicating the value. It indicating the value. Let us take 70. Like that I can represent the value 70. Or else, so or else if I want to access that particular data member, so 1 minute. So A means nothing but what A represent, it represents the 70 because of we are assigning the 70. So that means in order to access this position value directly, I can use the name of this variable A. Suppose through this x, if I want to access this particular 70, how I can access means this x is, if I specify directly x, if I directly specify the x means what this x indicates. So this x indicating the value of x. What is the value of x? Value of x is nothing but 4001. Suppose I want to retrieve the value which refers this x. I want to retrieve the value which refers this x. So if I want to access that one, so what I have to do? Simply I need to specify that one as star x. So if I specify this one, that star x is nothing but it is a reference variable. It is a reference point. Where it will be referred? So it refers to the x which it points. X which it points. So which it points to this particular 70. So that means then it retrieves the 70. It retrieves the 72 presents. Okay. So like that, you can access the your data values through a pointer variable, through a reference variable here. So why we are going to this reference and all these things means so at this point usually we can observe there is a wastage of memory because of already have the memory. I am already allocating the memory for the integer a and directly. So directly I can access that values. Why I am going to this reference and accessing all these things means here. So at this point, it may be wasting of the memory. At this point, it will be wasting of the memory here, that pointers. But while you want to work with the dynamic memory management, means during the program execution, if I want to allocate memory and I want to use that memory here, then these pointers are very useful. They are very helpful. So usually in your computers, for your variables, there are different type of memories allocated for us. That is stack memory and heap memory. Later I will discuss about that one. So if I want to utilize the heap memory, so normally if I declare the any ordinary variables, so these ordinary variables are stored in a stack memory only. So in addition to the stack memory, we have some heap memory also here. So if I want to utilize that heap memory, then I want to go for this pointers concept. So these pointers are only providing the capability for utilizing your dynamic memory. That is a heap memory here. So that is a extra. We are having some extra memory in your main memory. So we can utilize that memory effectively for your programs. Okay, for that point we are using this pointers concept here. Okay, so at this point we have to remember that a pointer is nothing but it is a simple one derived data type and which is capable for storing the addresses as their values. It cannot be storing the normal ordinary values as their values. Only they are storing the values of addresses of the other variables here. So just now I am discussing this one. Okay, if I declare a one ordinary variable, so then this is the ordinary variable that is created. So with the address some 4000 it is created. So if a pointer is created, then the pointer is created with some address location 4036. Now I want to give this pointer as a reference to my x here. Then I want to store this x address of that particular variable in this position. Then it is simply nothing but the reference to this particular location. Okay. So then in order to access this data value here, I can access through this direct variable or through this indirect variable. So simply the pointer is nothing but it is an indirect variable for accessing the data numbers available in an appropriate location. If it is pointing to that memory location, only it is capable. Otherwise, you cannot access that particular data value here. Okay. So just simply how I can declare a pointer variable. If I want to work with the pointer variable, so what is the way we are using in your C means so your pointer is nothing but it is a derived data type. So that's why first you need to use your primary data type. So my primary data type here, what type of data type I want to use, type of pointer variable here I want to use. So that data type I need to specify here. Once I specify this data type, so then what I have to do simply, I need to specify my data type. Next, star symbol. This is called as an indirection operator. It is called as an indirection operator. So star, then your variable name, pointer type variable name. What pointer variable name I want to specify, that you want to specify here. So here, if I want to create a one, suppose if I want to create a pointer variable, so integer pointer variable I can create like this, int star b. Suppose floating point type variable if I want to create, then I can specify the float, then pointer variable name. So that is a float star b, like that floating point. Similarly, double type if you want to create double star b. Suppose if you want to create a character type character star, like that you can declare a pointer variable of either integer type or float type, character type or double type. So whatever the primary data types are there, that type of pointers I can create. So why I'm creating that type of pointer means that pointer, suppose if I create an integer pointer, this pointer is only refers to the integer type data values only. It not refers to the floating point. Okay, so that means if I have the some floating integer type data values, if I want to give the reference to this integer data type value, then I want to create only integer data type only. So I cannot create a float type, and that float type cannot be points to this integer data type. So that's why whatever the data type values we are having, in order to find that type of data values here, we need to go with that type of pointer type only. Okay, so like that I can declare a pointer. So the simple declaration of my pointer is nothing but data type, and then indirection operator star, and then pt name like a pointer name here. So you have to specify, then a pointer variable is created. So once a pointer variable is created, okay, so what are the different styles we are having? Where I want to place that star symbol while you want to declare the pointer here. Means we can place the pointer variable into star space p, like that I can declare it is valid, or int space star p, that is also valid, or int space star space p, that is also valid here. So you may place your star symbol either nearer to your data type, or either nearer to your variable type, variable name, or in between your data type and your variable. You can also specify in that appropriate places here. Okay, so like that you can declare your pointer variables. So in any way you can declare here. Okay, so then appropriate matching. Suppose if I'm creating that particular thing, then appropriate matching it will be takes place here. Okay, so similarly you can declare the multiple declaration maybe takes place into one line only here. So directly in one line I also specify into star p. Then star p is treated as a pointer variable. X is treated as an ordinary variable. Star q means this is treated as a pointer variable. Like that, your all type of integers, either that pointer types or maybe either ordinary types, you may be declared into one single line. Okay. So also you may be different styles of matches you may be declared for this one. For let us example, x is a ordinary variable here, and star p is a pointer variable, and y is a ordinary variable. Then I can specify like this: x is equal to 10 means it is an ordinary variable, so that's why directly I can assign the value to it. Okay, 588. 588. Just you raised your hand. Is there any problem? $534.
No problem.
No problem.
No problem.
Okay. So like that, x is we declare here. That is ordinary variable. Next, y is equal to star p. So what is the meaning of this y is equal to star p? Means that y is a ordinary variable. Star p means a represent. It is a reference to p. Means a p. It is a p. What it refers? That reference value maybe you can consider here. So the star p is equal to 20. Okay. I will show an example how I am working with this pointer. So simply you can understand that program. Then you can clearly understand how your pointers may be works here. Okay. So just I'm going to give C++. So just to go to file, new. So pointers related. So as usual, I want to include the header file hash include stdio.h. Next void main. Now here I need to declare the in one line only, that is into first ordinary variable x. Next declare the pointer variable start x and start. So now first what I have to do is here I need to assign x is equal to 90. Let us take x is equal to 90. Next what I have to do is, so my pointer variable p is reference to the address of my x. So what does it means? Means here my computer is allocating the memory for x. Let us take this is x. Okay, so this is x memory location. So next my computer is also allocating the memory for p. Okay, so x is equal to 90 means the 90 is stored into my this location x, and p is equal to address of x means for example for this x address location suppose 400 is creating the address for example. So then p is equal to address of x means so in this p the address of x means address of x is nothing but 400. So that 400 is stored into this particular memory location. Like that my computer is allocating the memory at this point. Okay. Now what I have to do is, so simply I want to first print it. First I want to display the printed x value. X is equal to what? X in x what value is there? Percentile d. So just I want to display the x value. That is my first value. What output we are expecting from this? Okay. Next. So this is my first thing I want to get. So first I am checking for this one. Okay. Let us take I am saving the program. Save as. That is to C program. So pointers example dot C. Just save it. Okay. Now check for errors, compilation. Is there any errors? No errors we are getting. Next we are going to execution. So what is the output we are expecting? Just observe. X is 90. So x is equal to 90, p is equal to address of x. After that I am displaying the, just after that I am displaying what? Printf x value. So x value is how much? 90. 90 is there, so that's why 90 is displayed. Okay. Now I want to add one more line. So now printf. I want to display the what is the address of x. So in percentile d I want to display it. I want to display the what is the address that is assigned to my x by my computer. So that address I want to display. Address of x. Okay. For my x, what is the address that is allocated? So here I am assuming that 400, but actually in my computer what it allocated. So just again save it, compile it. So no errors. Next execute it. So now check it. What is the address? Okay, x 90. That is my value, first line. And second line is specifying the address of x is nothing but some 23,58,850. This is the address allocated by my computer for my this x variable. So here I'm assuming that 400, but actually in my computer, what is the address allocated for that one? That is this one, 23 lakh. So at this point, it will be allocated. Suppose now close this one, and again you compile it, and again execute it. Now, what is the memory result for that? The same memory. That is 23 lakhs 58,852. This memory is allocated for this X variable in my computer. Okay. So now what I have to do is, so like that I can retrieve the X of my value. Now next line. So next line, what I am doing here, printed. So what I have to display, what is the P value? What is the value is there in P? That is percentile D. So let us take only P. What it display? Whatever the value that is there in P. What value we are expecting in P? So here the line is P is equal to address of X. For example, I don't take this line. Let us take, I want to put this line into comments. So I don't take this line. P is equal to address of X. So then what will be the value of P? First I'm checking for that. If I'm not assigning the address of, if I'm assigning, now compile it, next execute it. So now what is the value? X is equal to 90, address of X is some 23 lakhs 58,852, and P is 1. Means no address is assigned, that is initial value, that is null value. That one is indicating about percentage, that is indicating the null. So null address is assigned, means initially my P is not pointing to anything. That indicates that. For example, if I specify the address of X, that is assigning the address of X for my P, that is P is equal to address of X, then what is the output? What is the value of my P? Then we check it. So now we check the address. What is the value in my P? Now we check it. X is equal to 90. Address of X is 23 lakhs 58,852. Now P value is 23 lakhs 58,852. So why this P is changed means here I am doing a one step, that is P is equal to address of X. Just I make this particular change. That is we are assigning the address of X to P. So that's why the P value is containing that value. Okay. Now with this P, I want to access the data value of X because of P is storing the address of X. So that's why through this particular P, I want to access the X value here. So then how I can access means printed simply. So that is nothing but star P. So if I want to access the value of that one means nothing but a star P. So that is percentile D. Then simply star P. Okay, so now save this program, compile it. So no errors in my program and execute it. So now check. So just put the new line character. Save it, compile, execute it. So now check it. So now check it. Okay, first line displays the first line. So this first line display the X value. So X value that is 90. Okay, and second line address of X. So whatever the address that is allocated for X variable, that address is displayed here. Second, third line is P value. P is what means P is storing the address of X. So that's why the address of X and as well as P both will be the same. So that is the same value it is assigned. Next line. So next line it will be displayed the star P. Star P means nothing but it is the data value. It is a reference to the data value where it will my P is refers. Okay. So that is simply 90. That will be referred. Okay. Okay. Like that I can use this pointers for referring the your appropriate variable here. So similarly, suppose if I want to display the address of my P, what is the address of my P? So P is also a one variable, but what type of variable? It is a pointer variable. So now I want to check that what is the address allocated for my P by my system. So that is nothing but percentile D percentile D. So simply that is address of P. So now check it, save, compile, no errors, execute. Okay, now check it. Now simply the addresses compared to previous, now my addresses are changed. Why it is changed means during in this process my computers that particular memory location may be used by the some other process also. So that's why the memory location may be slightly changed here, just you observe. But the assigning of address location for X and that same address I am storing into P is not changed here because of both will be the pointing to the same address here. So star P indicating about 90. And next this one, that is the address of pointer variable. What is the my address of pointer variable? 23 lakhs 58,848 is the memory location that is allocated for my pointer variable, that is P. Even though P is declared later, but the whenever I'm giving the star. Okay, so that's why in this way your pointers you may be using for referencing the some other variables here. Okay, so
Sir,
just 1 minute.
తీసుకోండి సార్.
Hello, check.
ఒకసారి స్టార్ ఈక్వల్ టు ఎక్స్ తీసుకోండి సార్.
Star
పి ఈక్వల్ టు ఎక్స్.
ఒకసారి చెప్. P is equal to X, huh? Okay, right.
ఈక్వల్ టు ఎక్స్.
Star P is equal to X, huh? Star P is equal to X. అంతేనా?
ఎస్ సార్.
Okay, now check. It gives error. Why? It gives no errors here. Why? Because of directly it will take the star P. So now you display the values. You are expecting any values from it? Why? Because star P is treated as a ordinary variable. I am assigning star P value to X. So that's why it gives a runtime error again. So it gives a runtime error. So that's why no lines are executed again. So clear? So it is not giving any compile time errors because of there is no syntactical mistakes in this. But while you want to execute this, suppose if I want to execute it, it doesn't give any output. So why it doesn't give any output means X is ordinary variable. Next I am specifying the star P is equal to X means now star P is treated as it is ordinary variable, it is a reference to X. But star P to X means it itself points to that X. So that's why we completely override this memory and override this memory. So means nothing data is there in these particular locations. So that's why nothing is displayed. So that is a problem. So that's why compulsory while you want to declare pointers, compulsory we need to specify this star symbol and symbol. Where I want to use this star symbol, where I want to use this address symbol means if I want to take the address of a particular variable, compulsory I need to use the and symbol. If I want to take the value which is pointed by that particular variable through a pointer, then I want to use the star symbol. Okay. In this way, suppose let us take it. I want to take some changes in this the other way. So what is the changes means here? So here I am not taking the star p and x is equal to 90, okay, but here, so just what I changed here, p is equal to address of x, so just I am taking like this. And after that, so what I am doing here is star p is equal to some 80, like that I am taking it. Now what happened? Now check it. So no errors. Now execute it. Now what happened? Just check the output. X is equal to 90, p is equal to address of x is equal to 90, next to star p is equal to 90. Just I specified here is star p is equal to 80. Means star p means nothing but what it indicates. It is a reference to x. It is a reference to x. So that's why in x memory location I need to assign 80. That means what it will be happen. Now this 80 is replaced by, and the 90 is replaced by this 80. So that 80 is discarded and 80 is replaced in that particular place. So that's why we are getting the x value as 80. The address locations may not be changed for that. And next, star p also indicating the 80, and next this. Okay, so directly star p x you cannot specify like that. Compulsory my pointer first machine should be pointing to any one memory location. After pointing to that memory location only, then you can perform your data value changes here. Okay, without it points to particular memory location, you can't do anything here. So in my previous, as you told, previously if I specify star p is equal to x, then star p actually pointer is not pointing to anything, but you directly what you told, so star p is pointing to x, means a star p value is taken as a x, but star p is reference to whom? We don't know. So that's why, so nothing will be shown to us. So that's why first my pointer variable points to something, then only we have to performing the remaining things. Okay, so I think you clear about this pointers concept. So just the same thing I will discuss. So next pointer initializations, how I am taking this pointer initialization means just I already discussed in that class. So any basic data type you need to take. Next your pointer variable. Next is equal to your expression. Data type pointer is equal to expression. And here this expression should be the another variable. It is the address of another variable. So you need to take here. So compulsory. Okay. So this is one simple example. I already discussed that example with the previous class. That is a previous example. Some different data values. So here I'm taking some different variables. So into I value variable, 486. Next one pointer variable. Next that is IPTR. IPTR is equal to address of IVR. Then if I display the simply IPTR value means what it display? It display the value of IPTR. That is nothing but the address of my I variable. And the next line, if I want to display the content of I variable is a star IPTR. So star IPTR is nothing but the content available in our 486. That is, it is a reference to that particular thing. Then that is display the 486. Okay. So like that, you may use the pointers variable. So I think this basic concept is enough. So simply, if I want to declare a pointer, how I can declare a pointer? So that is the thing, and how I initialize the pointer. So these things you require at this case. Okay. Next concept we are going to dynamic memory management. So dynamic memory management, what does it mean? Means dynamically memory is we are utilized by our program here. So up to now, whatever the things that you have discussed, So these things may be using the static memory allocation. Static memory allocations means my memory is allocated at compile time only. Suppose if I declare the variable int a, when memory is allocated, the memory is allocated at the compile time only, not at a program execution time. So similarly, if I declare one array variable int a of 10, so 10 memory locations are created for you. When these 10 memory locations are created, means at the time of program compilation. That is at the time of program creation only your memory is allocated. So that type of memory allocation is called as a static memory allocation. That is static memory management. That is. Now what is this dynamic memory management means? Our memory is not allocated at a program compile time. It is allocated during the program execution. Why we are going to this program execution time? Means here. So suppose if memory is allocated in compile time, suppose if you take the array int a of 10, if I take the int a of 10, but memory is how much it is allocated? 10 memory locations for allocated for us. Suppose if our integer 2 bytes, then 10 into 2, total 20 bytes of memory is allocated for me. But during the program execution time, suppose I want to take the only 5 variables, 5 values only for my array. Instead of 10 values, I need to take only 5 values I am taking. That means only 5 memory locations are utilized. Remaining 5 memory locations are unused. That means we are wasting the memory. We are wasting the memory here. So that wastage of memory we need to overcome. We need to remove that particular wastage of memory here. So that's why we are going to allocate the memory during the program execution time. So during the program execution time, how much memory we require, that much of memory only you have to allocate and we have to use it. Okay, unnecessarily we are not allocating the memory, we are not wasting the memory here. Okay, so if your memory is reserved for me here, no one can be used that memory here. Completely that memory is reserved for me only here. So in that reserved memory, if I am using the only some portion here, means the remaining portion is unused here. If it is unused, no one can use it here. Memory is available, but no one can use it, means it is a wasting of memory. Suppose how much required, I want to use that much of only here. Unnecessarily, I am occupying all the space, means it is a burden on my system here. So that's why we use this dynamic memory management concept here. So this dynamic memory management concept is called as the memory allocation process. It is a memory allocation process during the program execution point. That is called as a dynamic memory management concept. Okay. So before we are understanding about this dynamic memory management, first we need to understand about the how memory is allocated for my programs, how the memory layout is looking for my programs. If I am writing the one program, how my memory is allocated in my computer, how memory is allocated in my program, means my memory is layout for any C program or any program if you consider. So the memory allocation maybe takes place into these 4 segments. So one is called as heap memory. That is first one is heap memory. Next stack memory. Second one. Next static or global segment. Next thing is static or global. Next static or global. Next code segment. What is this code? What is this static global? And what is this stack memory? And what is this heap memory? Means here. Suppose if I create a one C program, in your C program, whatever the lines we are having, suppose in my previous program I declared like variables int x and int star p, next int y, next p is equal to address of x, or printf percentile d sum x. Like that I want to write the some statements. These all the instructions in your program, whatever the instructions that you are having in your program, all the instructions are stored into this code segment. All the instructions are stored into this code segment of your computer's memory. So your computer is allocating the memory layout in this manner. So heap memory, stack memory, and static or global segment, and next code segment or text segment. in your program, whatever the instructions are, whatever the lines that you are having, this code, that code is stored into the code segment. Okay. Next, in the static and global segment, what are stored in the static or global segment means that in the static or global segments, your global variables, whatever the static variables or global variables that you are declared in your program. Global variables means that, so in global declaration, whatever the variables that you have to declare, that variable is treated as a global variables. That is, your global variables are either any variables that are specified as a static variables. That static variables. These static variables are stored into this segment. And next, your function calls. That is, whatever the function that you are calling, that function calls are your local variables. These are all stored into your stack memory. These are all stored into your stack memory here. Okay. So basically, if you create any C program, so my C program instructions are stored basically into these three segments. So later I will discuss about this key memory. First we will discuss about these three segments here. So in these three segments, what portion of your program is stored in which portion of this particular thing means that your program lines, that instructions are stored into this code segment, and global variables are stored into a global and as well as static variables are stored into this static or global segment, and your local variables and function calls, whatever the function calls that you have to specify into your C program are stored into this stack memory. Okay, so let us observe one example. So I will discuss a few example here. Okay, so just to understand the definitions. Text segment means the text segment is also known as a code segment, or simply it is as a text, is one of the section of your program in an object file or in memory which contains all your executable instructions, that is printf, scanf. So these are all type of instructions, whatever the executable instructions, for loops, while loops, all these instructions are stored into this text segment of your computer's memory. And in the data segment, what it will be stored means data values. So your data values means nothing but, so your global variables, whatever the global variables that you have to declare, or whatever the static variables that you have to declare, are initializing your variables. So these are all stored into the data segment. Next, whereas stack is a special region of your computer's memory that stores temporary variables. So in your program, whatever temporary variables are there, temporary variables means your automatic variables or register variables. So these are all considered as a temporary variables. These temporary variables as well as the functions, the function calls, that whatever you are created, these are all stored into the stack memory. And in the stack memory, how they are evaluated means they are evaluated in the form of last in first term. So whatever the last variable that will comes into that memory location, that will be evaluated first, and after deleting of this one, next memory location or next data value maybe it is used here. So I will explain about these things with example. So just to understand. So let us take this is my program. Suppose I can observe my program. So let us take my program is I'm writing like this: hash include stdio.h. Next, I need to declare one variable into total. So how this variable is treated? This variable treated as a global variable because of I need to specify in a global declaration section, not in any function. So next I need to take one function. So this is one function. So my function name is a square, and which takes the argument int x, which returns the data value int. Okay, and what it returns, simply takes the x and return the x into x. X square value is returned by this function. So for that purpose, I'm writing this function. Okay, next I'm writing the one more function here. So what is my one more function? It takes the two argument x and y and compute the square of sum. That is simply z is equal to square plus x plus y. So square already this function. So square of this x plus 5 and that result is assigned to z and return the z. That means here simply it returns the x plus y square. Simply if I'm passing the x and y. Like that I'm writing the two functions. So this is function 1 and this is function 2. So two functions I'm writing here. Okay. So this is one function, square function, and this is one square of some function and one global declaration variable. Now I'm coming to my main program. Now in main program what I am doing here is a is equal to 4, one variable I am declaring, and b is equal to 8, one more variable I am declaring here. Next I am calling the square of some function with these two variables a comma b. Square of sum a comma b, whatever that a value, that square of sum is written the sum result, that is total, and that total I want to display here. So this is my simple program I write. Now this particular instructions where it will be stored in my computer's memory means here this instruction, that is total, printf, these are all stored into my this particular memory segment. So this particular memory segment, that is this is code segment. In this code segment that will be stored. So that will be stored into this code segment, that instructions. Now in the static or global, what variables are stored in the static or global? Means here, so in your static or global variable, so what variables are stored means here, the variables that is in this x and y we are having, this x and y. Okay, that xy, that is not xy, static and global variable means here, that is global variable is total. So this global variable total is stored into this segment. Okay, so what variables or what portion of your program is stored into this memory segment means my code segment, that is whatever the code that I am specified here, that is the total is equal to square of sum of AB. Next printf output of %d total, that is I am specifying these things. So these are stored into this segment, this code segment. These are stored into this code segment. Next, in static or global, what portion of your program is stored means the global variable. So in this global variable, what we are having? The total variable. The total variable is a global variable. And any other static variables we are having, no static variables are there. So that static variables are, that global variables are stored. That means that the total variable is stored into this memory location. Now in the stack, what memory is stored means what variables are stored, what portion of your variables are stored into the stack memory means in the stack, first this AB are stored first in my stack memory. First AB is stored, and above this AB, what variables are stored means this SOS, that is square of sum related function, because of in this what function I am calling, square of sum I am calling here. So first AB variables, next square of some variables. Square of some variables are nothing but xyz. So this xyz are stored, and above on this next square related, because of this square of sum is calling the square function. So that's why that square related variable x, that x is stored in this. Okay. Now how this particular thing is evaluated means first it evaluates this thing, next evaluate this thing, next evaluate this thing. Okay, so first what it will be, it comes and it will be first comes to the a is equal to 4 and b is equal to 8 values with that particular thing. So it will be goes to this particular portion. Okay, that is square of AB. So square of AB comes to this portion. What is the AB value, x value, and b values that comes to this portion? At this portion, it will be comes to with the x value as, that is 4, and b value as 8, that is 8 plus 4, 12. So at this portion 12. That means this x value is here 12. So it will comes with 12. So first square is evaluated with 12. Next comes to this. Then this will be assigned to z. So then that z now comes to this portion. Now finally this statement is displayed. So lastly inserted thing is this X. First it is evaluated, next it evaluated, next finally it is evaluated, finally empty the my memory. Okay, like that in this stack, your all temporary variables are stored. That is your local variables or your function calls. These are all stored in this particular. Whereas the permanent variable means that until your program execution, this total variable is not changed. So that is stored into the global location, and the code part is stored into this memory location. Now, this particular up to whatever the program we have discussed, we are just working with up to this portion only. Now, my dynamic memory management comes into this utilizing of this memory. If I'm using the dynamic memory management concept, then we are utilizing this heap memory. So that means that my memory size may be increased. Okay, so that memory we are using and we are working with that memory. Okay, so I will discuss about that one into our next class. So that dynamic memory management concept, because of time is over. Okay, so is there any doubt regarding to this point? If you have any doubts, you can ask. Just you raise your hand.